Okay, so here we have problem number 2 from week 2. Infinite plane of charge. Calculate magnitude of the force exerted on a charge Q by infinite plane sheet with a surface charge density sigma. So the formula is basically, so this is second problem from week 2. So F is equal QE and Q is equal, E is equal when there is infinite plane sheet, which is sigma divided by 2 epsilon naught. So that's it. And the next problem, third problem, it's known that electric force of repulsion between two electrons is much stronger than attractive gravitational attraction. For two electrons at distance r apart, calculate the ratio of the size of the repulsion to that of the attraction. So basically you have to find the ratio between Fe divided by Fg. Fe is equal to K Q squared of the electron divided by the R squared divided by G mass of the electron squared divided by the R squared. Okay, so now next force problem. The three charges Q1, Q2, Q3 are located in a straight line. The position of Q2 is 0.25 meter to the right of Q1. Q3 is located at 0.18 meter to the right of Q2. The force on Q2 due to its interaction with Q2 is directed to the, so basically you have to answer the question. So here we have Q1, we have Q2, we have Q3. So the distance of this one is 0.25. This distance is equal to the 0.18. Okay. Now the force between Q2 and Q3 is directed to the left if two charges are negative. Okay, so in the first case is directed to the left if two charges are negative. So it's true, it will be directed to the negative if two charges are negative because it will be repulsion force. Now in the part B, the right if two charges are negative. So to the right if two charges are negative, it's wrong. It's wrong. This is right. And part C is left if two charges have opposite sign. So it says left if two charges has opposite sign. Since it's opposite, it will be attraction. So it's wrong. Okay, and so on. So the last part in the above problem, if Q1 is equal to the positive charge and Q2 is equal to the negative charge and Q3 is equal to the positive charge. Okay, I'm not putting the magnitudes. So calculate total force F net on Q2. Okay, on Q2. So he says use plus sign for the force directed to the right. So whatever force is pointed to the right, we use positive sign. Okay. Now, since the force between Q1 and Q2, since the opposite sign, so the force F12 will be pointed to the left, and then also Q2 and Q3 are the opposite sign, so that means they will attraction, so it will be pointing to the right. So that means let's calculate F1 and F2, which is K Q1 Q2 divided by the distance squared. You have to calculate it. So whatever is the number you will get, it will be negative since it's pointed to the left. And then you have to calculate F23, which is K Q2 Q3 divided by the distance squared. Now distance between Q2 and Q3. So the net force on Q2 will be F net on Q2 will be the F 2 3, which is pointing to the right, is positive, minus f1 2. So that's it.